Hello everybody, another video on algebraic division. This time looking at algebraic fractions which include a bit of addition or subtraction. You might just have watched a video, possibly, especially if you're taught by me, on the similar sort of thing but with some multiplication. We're going to look at questions like the one at the bottom here. If that looks to you like something that won't pose any challenges at all, then you probably need to get out more. And it's certainly possible you don't need to watch this video. But if you are not sure how to go about it, read on or listen on. Let's look at that same question here on the next page and let's have a go at it. Okay, well, if you've been watching the one, if you watched the one on multiplication, division with multiplication, you'll remember that we multiplied anything we could multiply on the top or the bottom of the fraction. And in that way simplified the expressions a little bit. In this case, I suggest that there's nothing we can do with 6ab plus 12a squared to express it any more simply. So we just need to get on with it as best we can. Here's the trick though, if we've got a algebraic fraction with some adding or subtracting that's been simplified as far as it can, what we're going to do is we're going to separate the two parts on top and rewrite the question with, as I say, the two separate terms on the top separated in this way, with the denominator written underneath each part. And in that way we can treat each of these as separate fractions or division problems, and we can simplify them as far as possible and see what we're left with. Let's look at 6ab over 4a on the left. 6 and 4 are both even, we can halve them both. We get 3 and 2. A on top and a on bottom means we can divide both parts by a. I'm not going to write the ones in there, but they're there, aren't they? We just don't need them because 2 times 1 is 2 and 3 times 1 is 3. On the right hand side, 12a squared over 4a. 12 and 4 can both be divided by 4. We get 1 on the bottom and 3 on the top. A squared and a can both be divided by a. A divided by a is 1, and a squared divided by a is just a. And so we are left with two fractions. On the left hand side, we're left with 3b on the top over 2. And on the right hand side, we are left with 3a over 1. 3a over 1 is just 3a, so I'm going to leave it as 3a. And that, believe it or not, is our answer to this problem. That's as far as we go. Yeah, it's that easy. Let's do another one. Okay, x minus 15x to the 4 is an expression I can't simplify any better than that at the moment, so we're going to leave it like that. But we will rewrite the problem with the two terms separated in that way, and by rewriting the denominator under each part. X over x is an obvious simplifier because x divided by x, anything divided by itself is not 0, it's 1, isn't it? They cancel out, we get 1 over 1. And on the right hand side, x to the power of 4 divided by x is going to be x to the power of 3, isn't it? And the x on the bottom is gone. Right, so we're left on the left hand side with nothing, with 1 divided by 1, which is 1, minus whatever's left on the right hand side, which I make 15x cubed over 1, which is 15x cubed. And we get an answer of 1 minus 15x cubed. And again, that's as far as we go. We'll do one more. Looks like the most complex because it is a little bit more than the most complex, but that just means that the simplifying is going to take a little bit longer. Again, the statement on top is unsimplifiable apparently, so we'll rewrite it as is. So we've got 12x cubed y cubed over 6 x squared y squared. And on the right hand side we have 8x squared y to the 4 over 6x squared y squared. There we go. Can we cancel on the left hand side? 12 and 6, divide them by 12. We get 2 and 1. X cubed and x squared can be divided by x squared, can they not? X squared divided by x squared is 1. X cubed divided by x squared is x to the power of 1, or just x. Just cross out the 3. And y cubed divided by y squared, same thing. We get 1 and we get y. Done there. On to the right hand side. 8 and 6, divide them both by 2. We get 4 and we get 3. X squared and x squared, divide them by themselves, they cancel out, they're gone. I won't put the 1 in, we don't need it. Y to the 4 and y squared, divide them both by y squared, we get 1 on the bottom and we get y. Y to the 4 divided by y squared is of course y to the 2, or y squared again. And what have we got left on the left hand side? A little bit hard to see sometimes if you're a little bit scruffy with your cancelling, so be careful with this. As you can see, I'm not always the most careful, but I think we're okay here. Okay, on the top, on the left hand side, we've got 2 times x times y is what I see. So we've got 2xy. And on the bottom we've got 1 times 1 times 1, which is not 111, is it? It's that, it's not 3 either. On the right hand side, 4 times, no x's, 4 times y squared, so we've got 4y squared over 3 times 1, 3. Great. I might be grown up and just get rid of that 1 here. rewrite my final answer as 2xy minus 4y squared over 3. Looks like you haven't done very much, doesn't it? But it'll help you one day. Thanks very much.